Okay, let's do some more problems. These are on page 292. So turn to that page. Do these problems. Let's work through the first one together. It says propane. I don't know if you can read it here, but on your book it says propane is a gas used for cooking and heating. How many atoms are in 2.12 moles of propane? So what we want to figure out, how many atoms. So we're saying, how many atoms, and we're given 2.12 moles. Okay, so if you come down here, follow the problem. Okay, 2.12 moles. Now this time we've got molecules on top because we want moles to cancel. So moles are going to cancel. So we end up with 6.02 times 10 to the 23rd on top. There are in this molecule of propane is C3H8, there are 11 atoms. There's 3 carbon atoms and 8 hydrogen atoms for a total of 11. So we've got another step here. So that's our second step, is 11 atoms per molecule. 11 atoms in one molecule. So we're going to take 2.12 times 6.02 times 10 to the 23rd times 11 and come up with 1.4 times 10 to the 25th. Now my picture's not very good, so hopefully you're looking in your book and you can see that a little bit better. Alright, try these two. Try and figure them out first, and then I'll go over them. Alright, so the question is, how many atoms equals 1.14 moles of SO2? So what we first need to do is convert to its represented particle, which for SO2 would be a molecule, and then from molecules to atoms. So in 1 mole of SO2, there are 6.02 times 10 to the 23rd molecules. Now I like that there is actually an abbreviation for moles, which is MOL, but there is no abbreviation for molecules. It makes a lot of sense to me. So I've canceled out moles. I've now got molecules, and I want to convert to atoms. So we're looking at SO3. So you can see there's 1 and 3, so there's 4 atoms. So we can say that one molecule, can't write that, SO3 is 4 atoms. So I'm going to take 1.14, I'm going to take it times 6.02 times 10 to the 23rd, and then times 4, and I get 2.75 times 10 to the 24th atoms. For number 6, it says how many moles are in 4.65 times 10 to the 24th molecules of NO2. So how many moles? I'll abbreviate moles to MOL. NO2 equals 4.65 times 10 to the 24th. I won't abbreviate molecules because there is no abbreviation for it. NO2. And pretty much one-step problem here. Convert that from molecules to moles. And we know that 6.02 times 10 to the 23rd molecules. Just remember, because this is technically over 1, so it's on top, and I need to make sure that molecules cancel, and I need to have moles when I'm done. And so that's how I kind of figure out which one goes on top and which one is on the bottom. Cancel those out. So take 4.65 times 10 to the 24th divided by 6.02 times 10 to the 23rd, and the answer for that is 7.72 moles. Alright, so hopefully that makes a little bit of sense to you. These are pretty straightforward. They're usually 1, sometimes 2 if we're trying to figure out atoms, but normally just kind of one-step problems. We'll get a little bit more later, but usually not too bad here. All right, we've been talking about moles for a while, so let's just kind of relate, because what happens is this is a really hard number to understand. Most people do not understand how big a mole is, how big the number is. So let's just give you some examples here to maybe make it a little bit more interesting. Um, if we had a mole of moles, a mole of those little furry animals that I showed you a long time ago, the mass of those would be 9.03 times 10 to the 22 kilograms. Okay, that is big. They would be more than 60 times the combined mass of the Earth's oceans if we had a mole of moles. If you spread them over the world, over the Earth, they would form a layer 8 million moles thick. You'd be walking on 8 million moles right now. And if we line them up end to end, they would stretch from Earth to Alpha Centauri more than 2 million times. Not just there, but there and back, 2 million times. So that it's a big number is what we are trying to get across here. All right. Let's talk about the mass of a mole of an element. If we want to figure out the mass of a mole of an element, like iron or something like that, it is the atomic mass expressed in grams. So take a look. Okay, we've got our periodic table. At the bottom, actually on this one, it's at the top. We've got the atomic mass, the mass numbers given there. If I write that number as grams, that is a mole of that particular element. What that would mean is, let's say we're looking at iron. Iron's mass number is 55.85. So what we're saying is, if I had 1 mole of iron, it would have a mass of 55.85 grams. And of course, in there, I would have 6.02 times 10 to the 23rd iron atoms. That's what they're saying. So for an element, for any element, we simply look at the periodic table, find the mass number. That's how many grams it's going to be, except for our 7 diatomic elements, which become a little bit of a problem because those are twice as much. So the mass of a mole of an element is known as its molar mass. By the way, molar mass is kind of a generic term. We could be talking, if we're talking about a molecule, we'd be talking about its molecular mass. If we're talking about an ionic compound, we could be talking about its formula mass. But molar mass is just kind of generic. It means all of those. So it's a good word to use, easier than trying to separate all those other ones out. So if you look on the periodic table, carbon, look at it where it is. It's 12.0. Usually, most of the time, we'll use 3 significant digits. 3 is usually plenty. If you want to go a little farther, obviously it's 12.011 or something, but 12.0. So take a look. Figure out what irons would be. Now we did that one. We said that's 55.85. Now figure out what oxygen's is going to be. Now it's a little tricky. If you put 16, you forgot that oxygen is diatomic. There's 2. It's an O2. So it actually is 16 plus 16, or 32. So if I have a mole of oxygen, I would have 32 grams of oxygen in 1 mole. Keep it in mind, diatomic ones, you got to double. Keep that in mind. Very common mistake people make. What if we're talking about a compound? Well, if we're talking about a compound, find the number of grams of every element, figure out how many of each one there are, add them all up. That's all you got to do. Let's go back. Okay. So, for instance, if we're talking about something like, let's say, NH3, what we're going to do is we're going to find what nitrogen is. Well, if I look on the chart, it's 14.0 if I go to 3 significant digits. And then there's hydrogen. And hydrogen there is 3 of them, so 3 times each one, and each one is 1.01. So it would be 3 times that. So the total here is going to be 17.03. So we're just going to add up every single element that's in there. Let's take a look at a couple of examples. Here we've got water. H2O says its molar mass is 18. Well, how come? Well, because it's 2 times hydrogen. We're just going to use 1 plus 16. That equals 18. Okay. What about glucose? C6H12O6. How do we figure that out? Well, 6 times carbon. Carbon is 12. Plus 12 times 1. Plus 6 times 16. Add all those up. Comes out to be 180. So you simply add up all of the ones that are in there. Okay, if we look at dichlorobenzene, commonly called mothballs. And you're just going to take 6 times 12 for carbon. There's 6 carbons. There are 4 hydrogens. So, add that. Add 4 times hydrogen. And then 2 times chlorine, which is 35.5. If you add all those up, you end up with 147. All right, the decomposition of hydrogen peroxide, H2O2, provides sufficient energy to launch a rocket. What's the molar mass of hydrogen peroxide? Well, add up H's and oxygens. So 2 times 1 plus 2 times 16. 32 plus 2 is 34. All right, try these. Try those at the bottom. Stop the video. Come back when you're done. All right, so number 7, we've got phosphorus, which is 31, plus 3 times chlorine, 35.5. And if we multiply that out, we get 106.5. So the molar mass of PCl3 is 106.5. Now this question is just worded a little differently. It says, what is the mass of 1 mole? But that's really talking about the molar mass. Now, of course, see, and this is why, what you learned in the last chapter becomes important, because now they use the words and you still got to know how to name it. So sodium hydrogen carbonate, what is it? Well, NaHCO3. So it's going to be sodium, which is 23.0, plus hydrogen, 1, plus carbon, 12, plus 3 times oxygen, 16. And that totals to be, if I did my math here, if I find the answer right, 84 grams. Well, Robbie, this is for you. The end.